All right, loves, let's talk about simulations. Simulations are probably one of the hardest parts about probability because we're actually putting it into action. So the first thing I asked you to do was tell me what a simulation was and to describe it. So we're talking about a simulation. It's an experiment that makes a prediction about a real life situation. So instead of saying, um, how many times would I grab an ace if I did it this many times? I'm actually going to go ahead and do it. So how do we break that into 5 steps? Number one is we need to figure out what the problem is and understand how we're going to model it. Number two is we have to decide what we think is true. So what do we think the outcome is going to be? Step three, based on that outcome, how are we going to model it? Are we going to flip a coin? Are we going to do a spinner? What's going to be the best way to do that? Step four then is to do that trial. So to complete that activity, to do the spinner, to roll the dice. And then step five is to interpret your data. So number one, what's the problem? Number two, what do we think is true? Number three, what model are we going to use? Number four, use that model. And then number five, let's look at the data. All right, looking at some questions. It says that Jamie, Lauren, and Mary are standing in line for lunch. How many different ways can they stand? Well, the first place has 3 options. Second place has 2 options. Last place would only have 1 option. 3 times 2 is 6 times 1 is 6. So there's 6 options. Melody is creating 3 pizzas and has 6 toppings to choose from. If she can't use a topping more than once, how many possible pizzas can she make? So she is making 3 pizzas. We have 6 toppings, and then 5, and then 4, and then 3, and then 2, and then 1 for our options because we're not going to use them more than once. And if we multiply this all the way out, we end up with 720 options. 720 options. How many ways can a line leader and a caboose be selected from a class of 25? Sorry, kiddos. I was just rethinking this one. Rewind. She's only making 3 pizzas. So we have 6 toppings to choose from the first time, 5 to choose from the second, 4 to choose from the last. So 120 options altogether. Sorry, brain freeze. Okay, back to the caboose question. How many different ways can we choose a line leader and a caboose? Well, when we're talking about the line leader, there's 25 options. Once we take that child out, there's only 24 options left for our caboose. 25 times 24 gives us 600 different ways to choose a line leader in a caboose. So if you ever want to know why it takes a while to make a decision, sometimes you have a ton of options. Carol and her 5 teammates are at a swim meet all in the same race. How many different ways can they finish? Well, first place has 5 options. Second place has 4, then 3, then 2, then 1. If we multiply 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 gives us 120 options for ways that they can finish. All right, Will needs to pick a new 4-digit password for his ATM card using the numbers 0 through 9. If the numbers can be repeated, how many possible passwords can he make? Well, for number 4, he has 9 options. For number 2, he has 9 options. For number 3, he has 9 options. I'm sorry, 10. I'm forgetting to count the 0. He has 10 options for each of the numbers because it said that he could repeat it. So 10 times 10 times 10 times 10 is going to give us 10,000 options. How many ways can 8 people stand in a line? Well, first one is 8 options, and then 7, 6, 5, 4, 3, 2, 1. Multiply that all the way out. There are 40,320 different ways that 8 people can stand in a line. Questions on these, as always, bring them to class. All right, this is probably one of the hardest ways that we can ask our question is whether or not we can use something to simulate and whether or and which way we could use our simulation. So trying to figure out the simulations is the hardest part. So first one, could you use a coin to simulate guessing a true or false test? Yes. I could say that heads is true and tails is false. There's a 50-50 split. Absolutely could do that. And then I could flip it 20 times or 10 times, depending on how many times I'm saying, or how many questions I'm saying are on the test. Could a 5-section spinner simulate guessing a true or false? No. 5 is odd. We need something that's going to have a 50-50 or equally likely opportunity. So this one is not going to work. Could you use a 6-sided dice to simulate guessing true or false? Yes. I could say that even was true and odd was false. I could absolutely do that. Could you use a bag of 3 colored marbles to simulate true or false? No, it's not going to be an equally likely situation. So that would not work. That's a no. Could a random number generator simulate guessing on a true or false test? Yes. Again, I could do true is even, false is odd. So that would work. And could you use a standard 52 deck card to simulate guessing on a true or false? Yes, I could do red is true and black is false. So that would also work. If you have questions on these, go ahead and bring them to class. All right, now this time we are looking at one type of simulation and 2 questions. So how would you use a coin to simulate a baseball pitcher throwing strikes with 50% of his pitches? There were 6 pitches attempted. I would flip a coin 6 times. I could say that head is strike and tails is a ball. So that would absolutely be able to do. How would I use a coin to simulate? A student gets half the fill in the blank answers. They attempted on a quiz correct. There were 10 questions. Flipping the coin 10 times, saying that heads is right and tails is wrong. How would I use a 6-sided dice to simulate a pitcher throwing? Again, same situation, but using a 6-sided dice. I could roll that die 6 times and say that odds are strikes and evens are a ball. Talking about the true or false question, I can say evens are right and odds are wrong. Using a spinner, it's a 4-section spinner with 4 different colors. And again, that same situation. I could say that orange and pink are a strike and purple and black are a ball and spin it 6 times. And for fill in the blank, same thing. I could say pink and purple are wrong, orange and black are correct, and spin the spinner 10 times. If you have questions on these, go ahead and bring them with you to class. All right, this time I'm asking you to do the probability. So last page, looking at probability. There are 8 gummies in a fruit snack, 5 are red, 3 are blue. What is the probability of picking a blue? There's 8 possible outcomes. 3 are in our favor, so 3/8. In a closet, there are 7 shirts and 6 pants. What is the probability that you will pick a shirt? There are 7 shirts and 13 options. There are 15 cows in a pasture, 10 are white and 5 are brown. What is the probability of picking a white cow, putting it back, and picking a brown cow? Now, obviously, we're not picking up cows, but, I was running out of questions. So there's 15 total cows. There are 10 white and 5 brown. So the probability of picking a white cow to start is 10. And then if I put it back, that means I still have 15 options. And I want to pick a brown cow. This time there's 5. Going to multiply that for my total probability is 50 over 225. In a bag, there are 9 chocolates and 11 hard candies. What is the probability you first pick a hard candy, place it back, and then pick a hard candy again? So there's 20 possible options, and 11 of them are hard candies. If I put it back, that means all 20 options are there. So this would give us 121 over 400 as our probability. You roll 2 dice at the same time. What is the probability that one lands on 5 and the other lands on an even number? Well, 5 is 1 option out of 6. Even numbers are 3 options out of 6. So I have 1 times 3 is 3, 6 and 6 is 36. So it's 3 out of 36. And then you flip a coin 4 times. What is the probability that each one will land on heads? Well, that's 1/2, 1/2, 1/2, 1/2, or 1 over 4, 8, 16. All right, loves. If you have any questions about your simulations or your probability, go ahead and bring them with you to class. Have a great weekend.